So, hello and welcome. In this video, we're going to start talking about momentum, right? Momentum and impulse. So, it's been quite a long time since we've made videos, and also I usually teach this section with reference to Newton's laws and give you a little bit about the grade 11 background. But we're going to jump straight into momentum. So, let's get started and see what this is all about. Right, so there we've got a good definition of momentum, and it says momentum, or the momentum of an object, is defined as its mass multiplied by its velocity. That is saying the following: P is equal to an object's mass times its velocity. So from there we can see that momentum is represented by P. Okay, so I want to start breaking that down, and we want to give it some terminology and see what it says. Right. Just clear the page and get a pen up there. What is momentum? Right? There's a word. Now, if I told you, let's see how we use momentum in everyday language. When you refer to somebody, you might say, the person's on a roll. When you see somebody on a roll and is gaining a lot of momentum in whatever he's doing, you say that person has gained a lot of momentum, right? The person's on a roll, perhaps. Gained momentum. Okay. So one of the definitions that we can consider momentum to be, one, scientifically we say it is mass multiplied by velocity. That's the one scientific way of putting it out there. The other way is thinking of what a momentum really is. It is a measure, and I'm going to put this in a red pen quickly. It is a measure or the quantity, right, or a measure of the motion of an object, right? That's the second definition that we've got there. A measure of the motion of the object. And I'm going to come and give you one a little bit later as well. So scientifically we say that to measure an object's momentum, we say momentum is defined as the object's mass multiplied by its velocity. Okay. Object's mass multiplied by its velocity, and also it's a measure of the motion of an object. So the faster an object moves, or the more it's moving, we can consider the object to have a greater momentum. So let's start breaking this down. Let's see what we can come up with. So I'm going to consider two cases, or rather two introductory examples. And the first one is I'm going to take object A and object B, and I'm going to put a little vector arrow there and consider those arrows to be the same. And let's give each of these some values. I'm going to say the mass of this object is equal to 10 kilograms, and the mass of object B is equal to 20 kilograms. While at the same time I'm going to say that this object has got a 10 meter per second velocity, and this object over here has got a 10 meter per second velocity. Now if I had to tell you calculate the momentum of the object, and you would say, well, Imad, momentum is just P equals mass times velocity. So to find the momentum of object A, I would say object A's momentum is the mass of object A multiplied by the velocity of object A. Now let's substitute those values and we say, well, mass of A is 10 kilograms and velocity of A is also 10 kilograms. And that gives me 100 kilograms meters per second, right? That's momentum. Now, the momentum of object B. Momentum of object B is the mass of object B multiplied by the velocity of object B. The mass of object B is 20 kilograms and the velocity is 10 meters per second. So the momentum of object B is 200 kilograms meters per second. Okay, so what I want you to do is I want you to think carefully about the two objects that I've given you. I've given you the first object and I've given you the second object. So the first and the second object, object A and object B, they've got the same velocities, right? But they've got different masses, right? Okay, what can we say about object B versus object A? Object B is heavier than object A, right? It's got bigger mass. So let's just put a note on top there and let's say we've got different masses but same velocities. Right? Different masses but the same velocities. Now if we start looking at the momentum, look over there, we've got 100 kilograms meters per second and 200 kilograms per meters per second. Clearly the momentum of object B, which we denote by P little pb, is greater than the momentum of object A. And the question is, why is that so? Because we kept the velocities the same. In this case, we can say that object B is heavier or has a bigger mass. Has a bigger mass. Right. So different masses but the same velocities. Now we're going to bring up another page and I'm going to say, well, let's study these things a little bit more. There's my object A, and I'm going to take another one over there and I'm going to make that object B, and I'm going to put in a vector. I'm going to say, well, there's one vector, there's another one there, right? Okay, so this one, let's add some masses again and some velocities. I'm going to say this one's mass is 10 kilograms and this one's mass is also 10 kilograms. But I'm going to say the velocity here is going to be 20 meters per second, right? And the velocity over here is going to be 5 meters per second. So based on that, we can say something about, firstly, the similarities and the differences between object A and object B. Well, the similarities are that both object A and object B have got the same mass, but their velocities are different. So here we can say same mass, the same masses, but different velocities. Right. So what does this mean and what does this show us? Well, and you can see obviously I've edited the vectors there to give you the following. Right, so let's calculate the momentum of each of these, right? Let's do it in blue. Let's say the momentum of A is equal to the mass of A multiplied by the velocity of A, and the momentum of B is equal to the mass of B multiplied by the velocity of B. In this case over here, the mass of A is going to be 10 kilograms and the velocity of A is 20 meters per second. So therefore the momentum is going to be 200 kilograms meters per second. And over here we can say, well, the mass is also 10 kilograms, but the velocity is 5 meters per second, and therefore the momentum is 50 kilograms meters per second. Now, which one has got the bigger momentum? Well, you can say, Mad, clearly 50 is not bigger than 200, so therefore 200 must be bigger than 50. So we can say that the momentum of A is bigger than the momentum of B. And in this case, the masses are constant, so we can say because A has a greater velocity. Right. Now this is a point I'm making. Firstly, because the formula P equals mass times velocity tells us two things, right? It's going to tell us that the momentum of an object is both dependent on its mass and its velocity. Now in the two examples that I've given you, this one over here, I've kept the velocities constant whilst adjusting the mass. And as we can see, even though the velocities are constant, when I make the mass bigger, I get a bigger momentum. Over here, I kept the mass constant. But so when I make the velocity bigger, I get a bigger momentum over there. Clearly, while keeping the one constant and allowing us to edit the velocities, we can see that momentum is dependent on velocity. And whilst keeping the velocity constant, we can clearly see that the momentum is also dependent on the mass of an object. So this formula in P equals mv, that denotes the momentum. This over here denotes the mass of the object, and this over here denotes the velocity of the object, right? Now, based on both these things, right, not just how fast an object is going, but also how heavy that object is, we need to think about something else and start using big words to explain what another definition of momentum is. And that big word is force. What about force? Well, I'm going to give you a hint, and I might even tell you the answer. The force used to explain momentum is we can also say that momentum is an indication of how much force is required to stop an object's motion. Sorry, I may have written that out without saying what I've written. So let me just read it to you quickly, that momentum is an indication of how much force is required to stop an object's motion. Now, what does this mean? If we go to the two examples, let's say you have two cars. One is a Mercedes-Benz and one is a Tata. And the Mercedes-Benz is a very heavy vehicle while the Tata is very light. If they were traveling at the same speed, it would be more difficult for you to stop the heavier vehicle. It would be more difficult to stop the Mercedes-Benz. Over here, let's assume I've got two Tatas, right? Both have the same mass of 10 kilograms, and the one is moving much faster than the other. It is going to be more difficult to stop the one that's moving faster, because more force would be required to bring that thing to a stop. And this is where we say that an object here has a greater momentum. So the bigger momentum, right, the more force will also be required to stop that object from moving. Okay,